Okay, so we've made a very, very simple program here. To start out with, we're saying the probability for the two jurors is also a half, and then the third one flips a coin. Mm-hmm. Here we ran 1,000 trials. We're going to try to count the number of. Sorry, did I say 1,000? 100 trials. We're going to try to count the number of times the three people got it right, and we're going to compare that to this probability, which is what we found that it was equal to. So for each trial, the first one we say if they got greater than the probability.
I guess for a half.
We got it backwards, actually.
Yeah, it has to be less.
It has to be less than.
But since it's a half here, or at least for the specific case, it doesn't matter.
That's right. So we say they have a probability of a half of getting it right. So if our random number is between 0 and random real gives a number between 0 and 1. So if it's between 0 and our probability, we say, hey, that person got it right. We increase for each trial that started at 0, now one person's got it right. If this person, now it would be either 1 or 2. And then the third person, they're always at a half. So here it's actually less than a half or greater than a half, doesn't matter. And then we have it. So let's take a look.
And they matched exactly.
In that case, they matched exactly. Is that what we would expect, by the way?
I mean, it should be nearby, but exact might be rare. Yeah, it's not exact, but it's still close.
It's close. So instead of 100, let's do 100,000.
That's pretty close.
Yeah, we're expecting. Am I on screen on those two things? Yeah, we're expecting this to be near a half. Maybe I can pull that up on the screen just a little bit more. All right, so now let's change the probability, because you said it didn't matter if it was like 0.99 or 0.01. So give me a new probability to try.
Let's do like 0.01.
0.01. Okay.
Say there. Almost the same.
So we got 0.01003 and 0.001. So again, what we're expecting. So this surprise that these numbers end up being very similar to each other seems to be borne out by our program. Why don't you give me a number for the probability?
Maybe at the other extreme, maybe like 0.99.
Okay, 0.99 with 1,000,000 trials.
Yeah, we're very close to it.
Now, while we were talking through the program, we originally had introduced a bug by accident. We had these being greater and this being greater. Remember that by accident?
Yeah.
We hadn't noticed that was because we were doing our tests with 50% probability. But let's see what would have happened had we not made that change.
So yeah, it's going to be basically the opposite.
Yeah, they're opposites of each other. So probably them getting it wrong.
Yeah, so we would have found not the result we were looking for, which happens all the time in computer programs. You can introduce just small little mistakes like that you don't notice. So what do you think about this problem?
Yeah, it's a pretty neat problem.
Are you surprised?
Yeah, I wouldn't have thought they would be equal.
Yeah, it's very surprising to me that these things are equal. What do you think?
Yeah, it's an interesting problem.
All right, hey, good job this morning, guys.